Okay, so in this video, we're going to be talking about elasticity of demand. And what this sort of does is it helps you determine whether or not a price increase will benefit your revenue or hinder your revenue. And this may not necessarily determine if you're going to make a particular business decision or not, because revenue isn't always profit, and profit is more beneficial to make your business decisions on than just purely revenue. So if we're looking at elasticity of demand, you can use it as a tool in order to make a business decision, but don't necessarily rely on it 100% if you're actually trying to put it into practice. Just use it as something to consider. So we're looking at f prime of over f of x as the relative rate of change of f of x. And so if we're given a function and we want to know how fast it's changing over a period of time, we can look at the derivative of that function over the function itself. And we can get a ratio in terms of how fast it's changing. Now we can look at what this sort of relation that we have is. And it turns out that f prime of x over f of x is the derivative of ln of f of x with respect to x. And we know this already. We talked about it a little bit a few sections ago, but this is a good relation to have in mind again if you're ever running into a situation that looks like this, because maybe you could potentially simplify your derivative a little bit or make it a little bit easier to work with if you know that this is a relation that you can use. And we also have a little bit that we need to talk about in terms of percentage rate of change, because oftentimes when you're talking about any sort of rate of change with respect to its own self or sorts, you usually want to talk about it in terms of a percentage. So these relative rate of change, it's good to phrase in terms of percentage rate of change if you're ever trying to look at explicit values or a concrete example. All right. So let's talk a little bit about what elasticity of demand really is. So we have the definition here. It's E of P is equal to negative relative rate of change of demand over the relative rate of change of price. And what this really means will come into view a little bit later. But we can think first off that demand can be rewritten as a function of price, or f of P equals demand. And so usually you're given some relation between demand and price in order to be able to find a relative rate of change of demand with regards to a price point. And if we have that function for our relative rate of change of demand, then it comes out as negative d of p of ln of f of p, which is kind of a mouthful. But you have this relation there, which is a composition of functions with a derivative. And since we already know what the derivative of that is, we'll be able to use this relation later on. But we also have a denominator here, which is the derivative of ln of p with respect to p. And this is just ln of p. And so we're also going to have a relation which will tell us what that derivative is, since it's with taking a derivative with respect to p. And so the whole E of p can be said as negative the derivative with respect to p of ln of f of p all over the derivative with respect to p of ln of p. And again, that's a mouthful, but that's what the relation is, and that's how it looks. And we can kind of simplify this relative rate of change of demand over relative rate of change of price into the formula negative the f prime of p over f of p in the numerator, all divided by 1 over p, since we have the relations from how the derivative acts with the natural log function for each of the terms. And this gives us a new relation where we can also flip that 1 over p and multiply by the reciprocal in the numerator and the denominator to get 1 in the denominator and a new formula in the numerator, which just simplifies to negative p times f prime of p all over f of p. And this end result here is what we're really looking for our E of p, or our elasticity of demand. And this will be useful for being able to figure out our revenue, whether or not our revenue is increasing over a certain period or decreasing over a certain period. And so let's look at how the different E of p values can affect our revenue. So say that we have E of p being less than 1 but greater than 0. We call this inelastic, or an inelastic situation. And so the demand, you'd have inelastic demand, and that implies that the demand is not sensitive to changes in price. And so anytime that you have that situation, you could increase the price and the revenue would increase because the demand would not decrease as fast as the increase in the price would. And so you have a greater change in price than you do loss of demand. For an elastic situation, where E of p is greater than 1, then we have the situation where demand is sensitive to changes in price. And so a price increase will reduce revenue. And what that sort of means is that if you increased up your price while it's the demand, while you have elastic demand, then the demand would decrease to a larger proportion than your price increase would. And so your rate of change of the rate at which your derivative is changing would be a negative rate for the revenue. And so in terms of what this means in general, it's better to potentially decrease your prices if you have elastic demand at that point with all the information that you've got. We also have the situation where E of p is equal to 1. And that means that the demand status is unit, or that you have unit demand. And what that means is that a corresponding price increase will be equally reflected with a decrease in demand. And so the revenue won't change over small changes while the demand status is a unit, or you have unit demand. And so the revenue derivative with respect to price changes would be 0 at that point. We can also take a look at why exactly the elasticity of demand is related to revenue. And so here are some equations and some math to work out why exactly the derivative of the revenue is related to elasticity of demand. So we have here, first off, that revenue is equal to price times demand. And we can rewrite our demand as a function of price because of the relation that we've been talking about having, this f of p function. And we can take the derivative of the revenue to get a product rule of price and demand. And this product rule, since we're doing the derivative with respect to p, would take this first term's derivative, which is p, so it'd be dp over dp, which is just 1. And we would multiply it by the whole second term to get f of p. And so this would be the first term in the derivative. And then if we wanted to find the second term of the derivative, we would take this first term in the original function, this p, and multiply it by the derivative of the second term, which is d f of p dp over dp, and we would get this as the derivative of f with respect with f prime of p. That's how you should say it. There we go. Which comes out for the second term here as p times f prime of p. And now that we've got this, we can do some algebra here and multiply by a complicated one, which is f of p over f of p on this second term here. And this will be fp times p, or fp plus p times f prime of p times this quantity where it's f of p over f of p. We can multiply that through and then pull out an f of p from both terms to get f of p times the quantity of 1 plus p times f prime of p all over f of p. And so this here is basically our e of p. We just need to put an extra negative sign in there, and that's how we would get it. And so the end relation between the derivative of revenue with respect to price is that it's equal to f of p times 1 minus the elasticity of demand, e of p. And so we get that end result there after doing some algebra to solve for it. And so this is how your derivative is related to elasticity of demand. And we can take a look at this graph that I've kind of drawn over here. And so if we have our R of P listed as the y-axis and our P listed as the x-axis, and we had a graph of what the revenue would look like, it might look something like this. And it would be something of this sort. And you would see that if you had an inelastic demand, that the revenue derivative would be positive. And so if your E of P was between, or if your E of P was between 0 and 1, like we have in the situation here, then our R of P would be greater than 0, just like we have here in this situation for inelastic demand. And if we also had the corresponding situation where it was elastic, and we had this E of P, which was greater than 1, then we would have a situation where the revenue derivative with respect to P would be negative. And so it would be decreasing. And so we've got this elastic situation with R prime of P being less than 0 and a decrease with respect to revenue if we have an increase in price. And then the last one would be the unit, which would be just this situation where E of P is equal to 1 and the derivative of the revenue is equal to 0. That's right there at that peak. And so that's the best possible situation to have. And so that's what you're kind of looking for, is trying to find situations which are close to unit demand for maximizing revenue. So, all right, that's about all that I have for this section. And I hope this kind of helps clarify what elasticity of demand is and how to sort of use it for maximizing revenue. All right, okay. Hope that this was helpful, and I'll talk to you guys again in the next section.